no harm in waving this little hand. Waves, you know, are nature's way of sending us a message. When we warm ourselves, we receive heat waves. Waves, in theory, may take the form of circles, and as the diagram shows, they're measured from the tip of one crest to the tip of the next. Although they may look large on the screen, heat waves are so small you can hardly imagine them. Modern science says that electromagnetic waves are roughly elliptical. On these waves, the blessings of electricity have sailed far in the cause of humanity. A light wave is another type. It's even shorter than a heat wave, especially the one we had last summer. If you find it hard to visualize 1/1000th of 1 millimeter, compare it with the thickness of a match, and that's 3 millimeters. Now here's a tensely dramatic study in sound waves. The sound waves are picked up by the microphone and photographed on the film. It's that range of spiky peaks on the left there. Electric waves are the raw material, so to speak, of the induction coil, which produces a high voltage from a low and causes a spark. And see what happens when the same thing is done in a much bigger way at a power station, when 10 million volts are let loose. Every picture tells a story, and this must be the sort of story that raises the roof. Though radio waves fill the sky in every direction, it might seem strange that they don't collide and interfere with each other. Let's experiment with some artificial waves in a glass-bottomed ripple tank. A light projects the waves onto a white screen, and you'll notice that the waves pass through each other. Actually, it isn't the water that travels, but the impulse. Imagine the impulse is a piece of seaweed. It may stay put, except for bobbing up and down. The waves of smell are what scientists call osmophores. Other people use a shorter word. And there are waves of passion. I said passion. Well,